Right now, there is a machine the size of a small car moving through absolute darkness at 61,000 kilometers per hour. No sun, no planet, no star within trillions of kilometers in any direction. It has been flying for nearly 5 decades, and even after all that time, Voyager 1 is only just approaching a distance that light can cross. In a single day. And here is what almost no one talks about. It is dying, not in a fire, not in a collision, not in some dramatic final explosion. It is dying the way deep space missions really die. Quietly, system by system, watt by watt. But here is the part most people misunderstand. The day Voyager 1 goes silent will not be the end of its story. That will be the moment its real story begins. Because after the last transmission, after the final instrument shuts down, after NASA can do nothing more for it, Voyager 1 will keep moving for centuries, for tens of thousands of years, possibly longer than almost anything humanity has ever built will survive. We did not mean to build something like that, but we did. Voyager 1 was never supposed to become a monument. It was built for a mission that already sounded extraordinary. Fly past Jupiter and Saturn, study their moons, their rings, their magnetic fields, and then, if possible, continue outward. That alone would have been enough. But Voyager turned into something bigger. At Jupiter, it revealed a world alive with motion, giant storms, layered clouds, and violence on a planetary scale. It discovered active volcanoes on Io, the first ever seen beyond Earth. At Saturn, it exposed the intricate structure of the rings and gave humanity one of its earliest unforgettable looks at Titan, hidden beneath a thick orange atmosphere. And then there was Europa. Voyager's images showed a surface that looked strangely young, smooth, fractured, with very few craters. That detail changed everything. It suggested that beneath Europa's ice there could be an ocean, a hidden ocean, a dark ocean, a place no sunlight had ever touched. Voyager was not sent to answer the question of life beyond Earth, but by simply looking, it helped create one of the biggest questions in planetary science. Those discoveries alone would have secured its place in history. But Voyager did not stop there. In 1990, it looked back and took one of the most haunting images ever captured, the pale blue dot. Earth reduced to a tiny point suspended in a beam of light. Every city, every empire, every war, every love story, compressed into almost nothing. Then the cameras went dark, and the spacecraft kept moving outward. In 2012, Voyager 1 crossed into interstellar space. That phrase gets used casually now, but it matters. Voyager did not just travel far. It became the first human-made object to pass beyond the heliosphere, the giant bubble created by the sun's particles and magnetic field. For the first time in history, a machine built on Earth was sending data from the space between the stars. And somehow, even now, the mission is not over. At least not yet. Voyager 1 survives on 3 small nuclear power systems, fueled by the heat of decaying plutonium-238. They were never meant to last this long. When Voyager launched in 1977, they produced around 470 watts. That was everything: the computers, the heaters, the antenna, the instruments. All of it running on less power than a kitchen appliance. But physics does not negotiate. Every year, Voyager loses a little more power. And when there is not enough electricity, you do not keep everything running. You choose what dies first. Think of it like a house where the power is slowly failing. First, you turn off the rooms you don't use, then the heating, then everything except one lamp in one room, knowing that soon even that will go dark. That is what NASA engineers have been doing for decades. Voyager launched with 11 scientific instruments. One by one, they have been shut down to preserve what little power remains. The cameras were switched off in 1990, permanently. The software that ran them was deleted. The ground systems that could interpret their images no longer exist. Even if you wanted to turn them back on, you could not. What remains now is a shrinking handful of systems, kept alive only because every extra month of data from interstellar space is scientifically irreplaceable. And here is the strange human detail that makes all of this feel even larger. Some of the engineers working on Voyager today were not even born when it launched. They are maintaining a machine built in the 1970s on vanishing power, billions of kilometers from Earth, using knowledge handed down across generations. A mission older than many of the people keeping it alive. Eventually, the math wins. One day, there will not be enough power left. The remaining instruments will go dark, then the core systems, then the radio link to Earth. And when that moment comes, Voyager 1 will fall silent forever. No final speech, no cinematic goodbye, just one last faint transmission crossing billions of kilometers of darkness. And then nothing. But silence is not the same as stopping. Many people think Voyager has already escaped the solar system completely. That depends on what you mean. Yes, it crossed the heliopause. Yes, it entered interstellar space. But far beyond that lies the Oort Cloud, the outer frozen frontier of the Sun's gravitational neighborhood. At its current speed, Voyager will take around 300 years just to reach the inner edge of the Oort Cloud, and roughly 30,000 years to pass beyond its outer reaches. 30,000 years ago, human beings had not built cities. There was no writing, no science, no recorded history. Voyager needs a time span like that, just to properly clear the farthest edge of our own system. And even then, it still will not be arriving anywhere. It will just be farther into the dark. The first notable close pass comes much later. In roughly 40,000 years, Voyager 1 is expected to pass within about 1.7 light-years of a red dwarf star called Gliese 445. This will not be an arrival. It will not enter orbit. It will simply pass through that region of space, fast, silent, and completely alone. By then, humanity may be gone. 40,000 years is long enough for civilizations to vanish, languages to die, coastlines to change, and entire worldviews to disappear. Voyager is fragile too, of course, but it is fragile in a different place. Here on Earth, time destroys things through weather, water, oxygen, and erosion. In deep space, most of that is gone. No rain, no atmosphere, no ocean to swallow it. Which means Voyager may remain recognizable for an astonishingly long time. And attached to it is the strangest part of all: the golden record. A gold-plated copper disc carrying sounds, images, music, greetings, and traces of life on Earth. Not because anyone expected it to be found, not because it was likely, but because someone thought that if a machine was leaving the solar system, it should carry a message. Not a weapon, not a warning, a greeting. And if Voyager survives, that message may outlast almost every physical trace of our civilization. So how far will Voyager go? Distance is almost the wrong way to think about it, because the deeper truth is not that Voyager will go far. It is that it will go on. It will outlast the mission that built it. It may outlast every city standing on Earth today. Long after the final radio whisper fades, Voyager 1 will still be out there, moving through interstellar darkness with nothing to guide it and almost nothing to stop it. No applause, no witnesses, no return, just motion, endless, silent motion. Voyager 1 began as an instrument. It became an explorer. Soon it will become something else entirely. A drifting artifact of humanity, A message that will probably never be read. A monument made not of stone, but of velocity. And long after no one on Earth is listening anymore, it will still be out there, carrying the smallest possible trace of us into the largest darkness we have ever touched. If you're here for the kind of space stories that stay with you after the video ends, subscribe.